Hello, this is a quick update on genetic programming. I've been working with frog leg. Right now I'm going to start the video of the frog leg feed. Turn it down. First I gotta scale it down because it by default is 640 by 480 and that's a little bit big to work with. Now we turn on the camera and lo and behold, there's a frog leg with a little LED at the end of it. And there's two servos here. One is at the hip and the other is at the knee. And I still don't even know what the lengths of these segments are. But I've incorporated the form genetic programming within this my Robot Lab software. And I put in a path of 4 points that I would like it to figure out how to do. If we go over here to the genetic programming tab, those 4 points right down here are the 4 points of the paths in order, and they kind of start I think up here 123 by 164. No, that's not right. They start here 123 by 164, then you move over to 249 by 164, 218 by 142, and then finally 130 by 142. So this is kind of a rough possible gait of a foot that it might take. And so this is what we want it to achieve. The genetic part is going to be building the program and moving the servos to some values. So if we go back to the camera now, we need a way to feed back that information. And in this case, let's see, what can we do? Color track, just put this filter in. And dilate, make the box a little bit bigger. Okay, right here is the LED, and over here is a whole bunch of reflection of light, because the office light is on now. And the next one to do, with smoothing makes it a little nicer to pick up. And then the last one is fine contours. I'm going to switch off the light now, and the reflected light's going to go away, and we're left with just the LED of the frog leg. Now we'll add the spine contours, and basically it's just going to find the center of this little LED blob. And what it will do is it will send off coordinates of where that is back to genetic programming, which will in turn determine the fitness of where those servo positions are. And how it does that is it finds the center of this little blob here, this LED, sends it back to the genetic programming, and determines whether or not the concocted program for moving the scenarios, how fit it is by how far away from 4 points it is when it tries to trace out a path. So now we'll just get it started. All we have to do, it's waiting for input right now. All we have to do is add the fine contours, and it should start shaking the leg. I wonder if I turn on. Oh, yeah. Okay, so you can see the coordinate system. I think the first one's actually size, something like that. I forget. But the second two are the coordinates of the center of the LED in each one of these frames that's been captured now. And if we go over back to genetic programming, we can see the paths being traced out. And here we're on individual number 25, generation 0. To get a better idea, I'm going to flip over to custom and then add camera on the left screen and add the genetic programming on output on the right screen. And there you see the desired path in yellow, and you can start seeing the actual paths of the LED as they're captured and traced out over it. 100, in this particular setup, there's 100 individuals in each generation, and through each generation, there's crossover and mutation, which mixes up the programs kind of as they try to get the desired behavior. So at at individual 99, what will happen is the best program or the best match for all the traces will be pulled out, and then it will be drawn in red. And then it will continue to make more programs and move the servos around more and more. Let's see, we're on at 86 at the moment. Big triangle path. 96, 97, 98, 99. So there. That's the best so far. And we can flip back to the genetic program page. And here's the red program. The red path is basically this program on the right, which is expressed as a tree. And basically the input from the data, actually just the X field, can be plugged into the X's in the tree program at the right, and you'll get the red path of the servos. It's kind of interesting because I thought this was a seeded value, but I guess it's a random seed. There's a different data that I was getting before, but this actually looks a little bit better. So the short story of it is that this will just continue to try different stuff, and depending on how the fitness program is made and mutation indexes and a bunch of other variables, the idea is that it will train itself to make that yellow path. I'm going to give it a little while and we'll see.